Good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on Jurins formula. So here we have a container and a liquid is filled in it and the liquid rises through a height h. So the first question is Jurins formula is, H is equals to 2t cos theta by dgr, where t is the surface tension, theta is the angle of contact, d is the density, g is acceleration due to gravity, and r is the radius of the tube. Second is variation of height with tension, so that is a straight line as shown over here. Then we have variation of h with theta, so that's a cosine curve, so it will be like this graph. And then we have variation with the density, so that will be a rectangular hyperbola as shown in the graph over here. Next we have variation of h versus 1 by d, so that will again be a straight line. If we take 1 by d as x, so the graph will be a straight line. Then h versus r will also be a rectangular hyperbola as it is inversely related to r, so the graph will be a rectangular hyperbola. Then if we take 1 by r as x, so h will be proportional to 1 by r will be proportional to x, so that will be a straight line. Then we have variation of h versus g, so that is again inverse relation, so rectangular hyperbola. Then we have h versus g effective, so that will again be a rectangular hyperbolic graph as they are inversely related. Now we have certain conceptual questions on what is effect on h if temperature is increased. So with increase in temperature, surface tension decreases, so height will also decrease. Then is what is effect on h if temperature is decreased. So with decrease in temperature, surface tension will increase, so height will increase. Next is what is effect on h if a detergent is mixed in the liquid. So detergent decreases the surface tension, so height will decrease. Then is if entire setup is placed in a lift, what is effect on h? So if it is placed in a lift, then replace g by g effective. So if it is moving upward, then replace g by g plus a. If it is moving downward, replace g by g minus a. If it is falling freely, then g effective will be 0. So according to the formula, it should tend to infinity. But practically, the liquid will cover the entire length of the tube. But when it will move out of the tube, its meniscus will adjust itself, because after that there will be no force of surface tension, as its surrounding will change. So our assumption that the force due to surface tension balances the weight is not going to work over there. So it will fill the full length of the tube, but at the uppermost point it will settle in a way that it's balanced, and it will form a meniscus, so that to have a balance structure. Now is if system is placed in vertically moving lift, what is effect on this? So as I have discussed earlier, replace g by g effective. So if you have any doubts, you can ask in the comment section. Thank you and have a nice day.